Astronomers have found what they say is the first confirmed case of a runaway, supermassive black hole. It's in the cosmic owl galaxy, which is actually a pair of ring galaxies about 8.8 billion light-years away. The rings appear as owl eyes as they get closer and closer to merging. Astronomers observing the cosmic owl found a long linear feature in the galaxy and wondered if it could be the tail from the first confirmed runaway, supermassive black hole. Now, new research confirms it. This is the story of a cosmic exile, the galaxy-sized supersonic boom it creates, and the chaotic collision that sent it flying into intergalactic space. Our story starts not with a bang, but with a line, a faint, peculiar, and impossibly straight streak of light in an image taken by the Hubble Space Telescope. Lead astronomer Peter Van Dockum of Yale University was looking at the image for something else entirely when he spotted it. In a universe filled with swirls, blobs, and spirals, this razor-thin line pointing away from the core of a distant galaxy just didn't belong. It was so weird that the first thought was that it had to be an error, a digital glitch from Hubble's cameras, or maybe a cosmic ray hitting the detector at just the right angle. But it was no error. The line was real, and it stretched for an incredible 200,000 light-years. To put that in perspective, that's nearly twice the diameter of our entire Milky Way galaxy. At the very tip of this enormous line was a bright knot of glowing gas. The simplest explanation also happened to be the most radical. They were seeing the wake of something unimaginably massive and incredibly fast, blasting its way through the thin gas that surrounded the galaxy. It was like seeing the V-shaped wake behind a speedboat, but on a galactic scale. The boat in this case was a suspected supermassive black hole. The idea was daring, but it was just a theory. All they really had was a mysterious streak. To prove it, they'd need a smoking gun, and that meant they needed a more powerful eye on the sky. Following the tantalizing clue from Hubble, the team turned to the powerful Keck Observatory in Hawaii. By analyzing the light from the streak, they made another stunning discovery. This wasn't just a line of gas. It was a stellar nursery. The entire 200,000 light-year long trail was filled with brand new hot blue stars. This deepened the mystery and added serious weight to the runaway black hole theory. The thinking goes like this. As this invisible behemoth plows through the sparse intergalactic medium, it's not just pushing gas out of the way. It's squeezing it. And that's the crucial step. Gas clouds in space can just float around for billions of years. But if you compress them hard enough, gravity takes over, causing them to collapse and ignite into stars. The black hole was acting like a cosmic plow, triggering a massive wave of star formation in its wake. What they were seeing was the aftermath, a trail of baby stars tracing the exact path of the fugitive black hole right back to its home galaxy. This was incredible supporting evidence. The data from Keck showed a trail of shocked gas and star formation, but the black hole itself remained unseen, a ghost at the head of the procession. They could see its wake, but they couldn't see it. To prove that a supermassive black hole was truly at the tip of that line required an even more advanced instrument, one with the power to see the invisible. It was a job for the Webb telescope. When the Webb turned its golden eye to the tip of that mysterious streak, it didn't just see more of the same. Using its NIR spec instrument, it analyzed the movement of the gas at the leading edge. And what it found was the undeniable, crystal-clear signature of a supersonic bow shock. A bow shock is what happens when an object moves through a fluid faster than the speed of sound in that fluid. Think of a speedboat pushing a wave ahead of it, or a supersonic jet creating a sonic boom. This runaway black hole is doing the exact same thing, but in the thin gas of intergalactic space. It's hurtling forward at an astonishing 1,000 kilometers per second. That's over 2.2 million miles per hour, a speed so fast it could get from the Earth to the Moon in about 14 minutes. JWST's data was breathtakingly precise. It showed a sharp, violent discontinuity right at the black hole's location. The gas ahead of the black hole was relatively still, but the gas just behind the shock front was being thrown back and sideways. By measuring a radial velocity change of about 600 kilometers per second across the shock, astronomers could calculate the speed of the object causing it. The numbers lined up perfectly. The light from the gas being slammed into us also blue-shifted its wavelengths compressed as it rushed toward us, confirming it was the leading edge of a colossal impact. As Peter Van Dockum put it, the shock signatures are crystal clear. This was the smoking gun. The JWST hadn't just seen the wake, it had seen the boom. It confirmed for the first time in history the existence of a runaway supermassive black hole, now officially named RBH1. So the evidence is in. A black hole with a mass of 20 million suns has been violently kicked out of its galactic home. The question is, how is that even possible? What force in a universe is powerful enough to dislodge something so massive? The answer lies in one of the most chaotic events in the cosmos, the merger of galaxies. For decades, theorists have predicted two main ways this can happen. The first is like a game of cosmic billiards. Imagine two galaxies merge. Their central supermassive black holes spiral toward each other. Now imagine a third galaxy collides with this newly merged system. When its black hole falls into the center, you have a chaotic three-body problem. The gravitational dance becomes unstable, and often the lightest of the three black holes gets ejected at tremendous speed, like a slingshot. The second scenario, and the one that seems more likely for RBH1, is gravitational wave recoil. When two supermassive black holes finally merge, they release an enormous blast of gravitational waves, ripples in the fabric of space-time itself. If this blast isn't perfectly symmetrical, the waves carry more momentum in one direction. To conserve momentum, the newly merged larger black hole recoils. It gets kicked in the opposite direction. This kick can be so powerful that it sends the black hole flying out of the galaxy entirely. The speed and mass of RBH1 are perfectly consistent with models of this gravitational wave recoil. The scale of this event is almost too big to wrap your head around. The black hole RBH1 is about 20 million times more massive than our Sun. It's been traveling for tens of millions of years, creating a trail of stars behind it that is 200,000 light-years long. The galaxy it was ejected from, located about 7.5 billion light-years away, may now be a galaxy without a supermassive black hole at its center at all. The confirmation of RBH1 isn't just a record-breaking discovery. It fundamentally changes how we see the universe. We usually think of supermassive black holes as permanent anchors sitting at the heart of their galaxies and shaping their evolution from a fixed central throne. This discovery proves that those thrones can be toppled. It suggests that the universe could be populated by a hidden group of wandering, invisible giants. These cosmic exiles could explain long-standing puzzles like galaxies that seem to be missing a central black hole or have one that's unusually small. The star formation they trigger in their wakes might also explain how stars can exist so far from any galactic disk. We're now seeing a whole new way to build stellar structures in the most desolate parts of space. This is just the first confirmed runaway. Now that astronomers know exactly what to look for, supersonic bow shock in a straight line of stars, the hunt is on for more. Future observatories like the Nancy Grace Roman Space Telescope will scan huge swaths of the sky and are perfectly suited to find these rare features. The LISA mission, designed to detect gravitational waves from space, might even be able to detect the recoil events themselves as they happen. What started as a weird line in a single image has opened a new window into the most violent processes in the cosmos. It's real-world proof of a 50-year-old prediction, a story of a cosmic mystery solved through persistence and incredible technology. It shows us that the universe isn't a static collection of objects, but a chaotic, evolving place where even the most massive anchors can be torn from their homes and sent hurtling into the void. If you found this journey into the cosmic unknown as mind-boggling as we did, be sure to hit the like button and subscribe for more deep dives into the latest discoveries from the Webb telescope and beyond. From a what is that moment to a stunning confirmation, the story of RBH1 is a perfect example of science in action. It's a testament to how our new tools are letting us see the universe in ways we never thought possible, confirming old theories and revealing a cosmos that is far more dynamic and far stranger than we ever imagined. The hunt for these runaway giants has only just begun. Thanks for watching. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.